discrete mathematics, graph and its applications in mathematics, and more specifically in graph theory. The graph is a representation of a set of objects where some pairs of objects are connected by links. The interconnected objects are represented by mathematical abstractions called vertices, also called nodes or points, and the links that connect some pairs of vertices are called edges, also called arcs or lines. Typically, the graph is depicted in diagrammatic form as a set of dots for the vertices, joined by lines or curves for the edges. Graphs are one of the objects of study in discrete mathematics. The edges may be directed or undirected. For example, if the vertices represent people at a party, and there is an edge between two people if they shake hands, then this is an undirected graph, because if person A shook hands with person B, then person B also shook hands with person A. In contrast, if there is an edge from person A to person B when person A knows of person B, then this graph is directed, because knowledge of someone is not necessarily a symmetric relation, that is, one person knowing another person does not necessarily imply the reverse. For example, many fans may know of a celebrity, but the celebrity is unlikely to know of all their fans. The former type of graph is called an undirected graph and the edges are called undirected edges, while the latter type of graph is called a directed graph and the edges are called directed edges. Show computer network here. By using graph, we can represent the computer network in real life as a graph so that more people can have better visual of how computers connected to each other. In graph theory, the degree or valency of a vertex of a graph is the number of edges incident to the vertex, with loops counted twice. The degree of a vertex is denoted or. The maximum degree of a graph G, denoted by G, and the minimum degree of a graph, denoted by DG, are the maximum and minimum degree of its vertices. In a regular graph, all degrees are the same, and so we can speak of the degree of the graph. The vertex with degree 0 is called an isolated vertex. The vertex with degree 1 is called a leaf vertex or end vertex, and the edge incident with that vertex is called a pendant edge. The vertex with degree n1 in the graph on end vertices is called a dominating vertex. There are many things that we can use graph in our daily life, like display the number of possible paths to multiple destinations with their weights to be considered to choose the shortest paths. Moreover, in computer science, graph plays a crucial role in which computer scientists and mathematicians cooperate together to solve the world problems. In order to do so, they can use adjacency matrix and adjacency list. Adjacency matrix, in graph theory, computer science and application areas such as sociology, an adjacency matrix is a square matrix used to represent the finite graph. The elements of the matrix indicate whether pairs of vertices are adjacent or not in the graph. In the special case of a finite simple graph, the adjacency matrix is a 0-1 matrix with zeros on its diagonal. If the graph is undirected, the adjacency matrix is symmetric. The relationship between the graph and the eigenvalues and eigenvectors of its adjacency matrix is studied in spectral graph theory. The adjacency matrix should be distinguished from the incidence matrix for a graph, a different matrix representation whose elements indicate whether vertex-edge pairs are incident or not. Adjacency list, in graph theory and computer science, an adjacency list is a collection of unordered lists used to represent the finite graph. Each list describes the set of neighbors of a vertex in the graph. This is one of several commonly used representations of graphs for use in computer programs.